Hi, in this video, I will be showing you problem number 22 of chapter 15, section 7. Use cylindrical coordinates. Find the volume of the solid that lies within both the cylinder x square plus y square equal to 1 and the sphere x square plus y square plus z square equal to 4. So we are pretty much using the cylindrical coordinates to find the volume of a solid. What is this solid made of? It's made up of a cylinder x square plus y square equal to 1 and a sphere x square plus y square plus z square equal to 4. So first let's recap what cylindrical coordinates means. So how do you change from rectangular coordinates to cylindrical coordinates in a triple integral? It's kind of very similar to the previous problem formula that we used. So it's triple integral over E f of x, y, z dv equal to, in cylindrical, it becomes theta runs from alpha to beta, then r runs from h1 of theta to h2 of theta, and z runs from u1 of r cosine theta, or it's a function of r and theta. So u1 of r theta, r comma theta to u2 of r comma theta, then f of r cosine theta, comma r sine theta, z r dz dr d theta. Notice here x is replaced by r cosine theta, y is replaced by r sine theta, and z remains as z. Then dv gets replaced by r dz dr d theta. So now let's discuss the solid. So here E is the solid region inside the cylinder x square plus y square equal to 1 and enclosed by the sphere x square plus y square plus z square equal to 4. So it is bounded above by upper part of the sphere and bounded below by the lower part of the sphere, bounded above and below by the sphere. The equation is x square plus y square plus z square equal to 4. In cylindrical coordinates, E is the solid region within r equal to 1 because x square plus y square equal to 1, x square plus y square equal to r square, so r square equal to 1, which means r equal to 1. So in cylindrical coordinates, the cylinder becomes r equal to 1 in this case, bounded above and below by the upper sphere and the lower sphere. Converted to cylindrical coordinates would be, so if you isolate the z here, it's 4 minus x square minus y square within radical. So it is square root of 4 minus r square above, and below it is z equal to negative square root of 4 minus r square. Now we have all the limits. We'll also write down the E, the solid now, with r theta z in cylindrical coordinates, r comma theta comma z, where theta runs from 0 to 2 pi, r runs from 0 to 1, and z is from lower part of the sphere to upper part of the sphere, which will be negative square root of 4 minus r square to positive square root of 4 minus r square. volume V of the solid denoted by V of E becomes triple integral. So it's integral E of dV, which is first integral is for theta, which is 0 to 2 pi. Second is for r, which is 0 to 1. The third integral is for z, which is negative square root of 4 minus r square to positive square root of 4 minus r square. Here it's only dv, that becomes r dz dr d theta. So it is integral 0 to 2 pi, integral 0 to 1, then r z, when you integrate with respect to z, and applying the lower limit and the upper limit, we get integral 0 to 2 pi, integral 0 to 1, 2r square root of 4 minus r squared dr d theta. We can separate the variables r and theta. They are both definite limits and finite limits. So it's V of E, volume of the solid, is integral 0 to 2 pi d theta, integral 0 to 1 2r times square root of 4 minus r square, which is 2 pi times I1. We will separately evaluate this I1 and plug it back into the steps. So where I1 is 2r square root of 4 minus r square dr, you can apply u sub. So 4 minus r squared equal to u, which is negative 2r dr equal to du. Then finding I1, we get square root of u negative du. Changing the limits to the new limits, when r equal to 0, u would be equal to 4. When r equal to 1, then u would be equal to 4 minus 1, which is equal to 3. So integral 4 through 3, square root of u negative du, this becomes integral 3 to 4. So whenever we switch the limits, we have to throw a negative sign. There is already a negative sign here, so it makes it positive. Integral 0 through 4, square root of u du, which is u to the 3 by 2 over 3 by 2 between the limits 3 and 4. Computing this value, we get 2/3 of 8 minus 3 root of 3. Substituting back into the step where we had V of E, substituting here, we get V of E equal to 2 pi times the value for I1, which is 2/3 of 8 minus 3 root of 3. Then simplifying this, we get 4 pi over 3 times 8 minus 3 square root of 3. If you look at the picture, we have a cylinder and it is intercepted by a big sphere which has larger radius than the cylinder. Then the middle portion is the sphere part, is x square plus y square plus z square equal to 2. It's equal to 4. And then the cylinder is given to be x square plus y square equal to 1. Then that part is the upper sphere. Then similarly you have the lower sphere, which cannot be shown in the diagram, but you get an idea of how the figure of this solid looks like, for which you have found out the volume. Hope this video helps.